Good morning, ladies and gentlemen. I hope you're all feeling suitably refreshed after the coffee break and you've had a good chance to network with your colleagues and some of our other speakers. It's my great pleasure to be able to introduce the next talk in our session today on open source automated marketing mix modeling, Project Robyn, from Meta, aka Facebook. And this is going to be given by Igor Skokan and Leonel Sentana. Igor is part of the global marketing science team at Meta, based here in London. Helping agencies and marketeers find true business value through solutions measuring audience, brand, and sale outcomes. Across his roles before this job and previously, his focus has been on the intersection of different facets of marketing effectiveness, using marketing mix modeling, holistic attribution, randomized controlled trials and experimentation, media insights, and open source. Leonel is a data scientist with over 10 years' experience in business intelligence and analytics. He's a marketing science partner at Facebook, which he's been for the last 5 years, working across Buenos Aires, Dublin, and Madrid. And his focus is on helping digital native advertisers improve their marketing investments and media mix through scientific measurement methods. Okay, over to Meta.
Thank you very much, and we're really excited to be here today and talk about open source automated MMMs or marketing mix models. We're gonna discuss all of that. So, this is us. Thank you, Charles, for introduction. So then I guess let's just get straight on with it. Probably many of you who are data scientists or marketing scientists in general have noticed that there is a huge disruption going on in our industry and in our ecosystem, and that can be mapped to many years back. But I think that 2018 was a pivotal year with GDPR have been passed, and when we decided as a society that we want to give more power to people to control what happened with their data. And it's the really right thing to do. Everybody should know what exactly is happening and why it's happening and so on. But ever since, the advertising ecosystem has been really evolving itself, and there has been different kind of regulations, CCPA, LGPD in Brazil, but also the providers of the mobile devices, Apple, etc., have started introducing more and more policies in which they started to limit tracking and limit the use of the data. So we expect this to carry on, and I read somewhere just recently that there is another 50 different regulations coming into from South Korea, Indonesia, South Africa, all around the world, around the same thing. Now, this is overall a really good thing for the internet and for companies operating in this space, but this is also impacting the ability, for example, for us as data scientists, as measurement people in general, to work with the data that we have. So, out of the many things that this is going to bring positively, there are some things that will become more difficult. For example, reaching people, or personalized ads, etc. But one of the things that's going to get more difficult as well is the measurement of the campaign results, because again, we might not be able to tie that exposure into the individual who got it. That said, the impact of the tools that are currently used in the marketing and measurement ecosystem is varied. So on one hand, you have things that are much more impacted, such as multi-touch attribution. Those of you who know what it is, it's usually based on sort of log-level, transactional almost data that has, on cookies and mobile identifiers that are no longer or much less available than they used to be. But then on the other hand, you have things like marketing mix modeling or econometrics or geo-experimentation that are currently less impacted, simply because they work with aggregated data that's already privacy safe, or in the case of things like MMM, this actually predates the internet, right? So doesn't actually inherit any of the issues that or challenges that have with it. And then somewhere in the middle, you have other things like the conversion experiments, where you may lose some parts of it, but largely knowing if someone is in test or in control group remains, you don't need to know a personally identifiable. So what happened over the last, say, 12 to 18 months is that marketing mix modeling, a very traditional technique, suddenly got all this interest from all over the world, from all over the verticals and so on. Even traditional, and we were just talking to the guys from King, please pop in, say hello to them. Even traditionally verticals such as gaming and mobile gaming that haven't been utilizing this sort of measurement have now warmed up to the idea of, by the way, what if we do it in an all in aggregated way and so on. And this can be traced into the changes to the ecosystem. So long sort of beginning, but we just want to make sure that the motivation for us doing this kind of work is really based in the changes in the ecosystem and policies, and I'm going to talk about a little bit more about that as well. Leo will bring you all the data science details, just so that's coming. So to super level set before we go any further is, so MMM is privacy friendly or privacy first. It's highly resilient meaning that it has been here for 50 years. It's probably going to be here for much longer. It's a time series regression. It's holistic. You can quantify marketing and non-marketing activities, so it's just quite unique as well, right? So there are some solutions out there that tells you, how my media and marketing is performing, but that's not what often the question is. How does the whole holistic business work? So what about the pricing, distribution, competition? Can that be also reflected? And MMM holds the promise of incorporating some of this data as well and measuring non-marketing activities just as marketing activities. And it's highly scalable and available, and within the hands of the current data science community, and sort of being rediscovered, almost, I would say. It's there is a saying, I think every generation discovers rock and roll. So I think with this feels a little bit like with MMM, it's oh wow, you can do all these things, right? But with the hands of, yeah, go on.
By the way, it would be great to know, guys, have you ever heard or applied MMM at any point? Can you raise your hand just to get an idea?
Yeah, so.
Okay, so we have 30% or so, guys, 25, great.
So you know how much pain and glory it can be, right? So to do it by hand or where it is. So it's yeah. Thank you, Leo. What does it in its essence? It's super straightforward, right? So you take the aggregated time series, and that's the privacy part. So you can have it very granular, daily, weekly, often. And then you solve a mathematical formula, solve a regression, and then you get a decomposition chart looking at the different statistically significant channels, and then you can work from there. But the cool part as well is that the marketing concepts can be sort of reflected when you're building these MMMs, right? So you can look at advertising ad stock, which is the kind of forgetting function, right? So you see an ad today, you're not going to immediately go and buy something, but it kind of builds in your head, and then you sort of forget the ad over time, and or the nonlinear response to any additional unit. So if you do more marketing, it's always going to drive additional response, but at a diminishing rate. So there is a point in time when it becomes sort of ineffective to start spending more. So these kind of concepts can actually be very reflected when building these models, which makes them super useful for sort of strategic and tactical optimization. Now, the challenge has always been, and Leo's going to really deep dive into some of it, is that the manual element of it has been always difficult. So if we have humans doing this kind of work, first of all, we all are humans, so we have bias, we have our own perceptions of how things should be, but not always may be accurate. And then, given the same data set, multiple data scientists would build completely, vastly different models, and that's kind of uncomfortable, right? So with some of the concepts like attribution, say last click, even credit. Everybody knows it's wrong, right? It cannot be even credit or cannot be last click. But at least it's predictable in its sort of inaccuracy, Right? So, given the same data set, we always arrive to the same number, safe. Anyway, we think that the modern way to do this is to actually incorporate machine learning and experiments in order to bring this. And this was the motivation for us to build Project Robyn. And I'm handing over to Leo in a second to talk about this. But it's really, can we bring some of the machine learning, some of the automation, some of the semi-automation into building MMM, minimize the human bias, try to remove as much as we can, in the same process, make it faster, more sensitive, more reliable, so we can sort of deliver insights faster and on a sort of continuous basis.
Yeah, and one of the main, differences you're gonna see from a regression, like a regular regression, sorry about the yelling, it's basically those three charts that he was showing before, those charts are actually the main difference. So we're gonna keep doing regressions, time series regression, as you may be used to if you work with product or in other areas. But these are the actual marketing concepts you have to have in mind, and are a main challenge for us to automate through the process of coding and optimization.
Yeah, so the vision to move MMM, contemporary MMM, to refresh it and bring it into a more modern machine learning, it was the reason why we built Project Robyn, and that's
exactly. So first of all, thank you very much for being here. Actually, Robyn, it's all about you. So the idea here is that we can share with you, create a community, and I'm going to talk about that later. But our full idea is to, you can get us later, and we can speak and even exchange thoughts about MMM. Again, as I said, usually regressions are very similar to MMM, but we have these different nuances, and the idea is that we all can make this MMM sort of analytics community move forward. If we go into the next one, let me go here. So basically what I was saying is, it's not just a code, right? Like when we talk about Robyn, as Iggy was saying, this is a semi-automated code which lives in R, so you can use it in R. For the moment, we're going to develop it in Python very soon. It's not just that code that semi-automates all the process that an analyst could do, but it's also a community. We have thousands of users that are already working on our Facebook groups, which we would like to encourage you to join. And we also have GitHub and the website and many different sources which you can pretty much reach out and discuss. So we've seen lots of different nice discussions, even methodological, even like very practical and tactical on the Facebook groups especially. So really encouraging you guys to go there and share your thoughts. And our main objective is that, right? Like to impulse the industry, make this industry better and better in terms of marketing modeling. When we work at marketing science within Facebook, our main objective is basically to help businesses grow and do it by being grounded in data and science. So basically, this is one of our main ways to scale it through open source techniques like that, like MMM, right? And if we, when we thought of Robyn first, when we started thinking about Robyn, we wanted to tackle 3 different problems. One of the first ones, which we're aiming to tackle, it doesn't mean it's not going to exist, is to minimize human bias. Because when we, of course, do any regression, not necessarily just marketing regressions, there's always going to be human bias that is embedded within it, right? So in the old state of like old MMMs, on old marketing mixes, usually they were more like manual and crafty, and it would require like manual iterations to pretty much define which is the best model or the best decision for those ad stock and saturation curves that Iggy was just mentioning. In this case, within Robyn, we're using, as you may see, machine learning and AI. And we try to iterate through the full hyperspace or parameters and pretty much try to define a set of objective functions and go after that to automate that process. The other aspect that we wanted to work with, and which is very important for marketing science, is the aligning with the ground truth aspect. This is very much like using randomized control trials. This is our main, gold standard, and you guys might be used to it. As data scientists, it's very, very common. But sometimes in marketing, people question that, right? So what we try to do here is to also say, okay, an MMM could be biased, then how can we, bring causality into it? We do it through experiments, and we are allowing that compared to all MMMs, which may have not been able to do that in the past. Now we can do it within Robyn.
And Leo, actually, this was one of our original ideas. Was that people ask us, so how would you do it? And we're like, yeah, right, this is a kind of concept. How would you do it? And then we're like, you know what? We need to kind of put some code out there, because otherwise it becomes very theoretical, right? So, and if one of you or some of you have been to some of the Facebook offices, there are a lot of posters, and one of the posters that says on the wall that says code wins arguments. And it's like, as long as you can kind of put a code out there and say, this is how we would do it, we can disagree, we can agree, it's replicable, people can make it better, and actually this is where it started from, yeah, and then we built the whole concept. But a lot of people are asking us, great, we agree to the idea of calibrate MMM with experiments or ground truth, but how would you do it?
Exactly, and that's the idea of providing a code, right, compared to maybe a playbook or some other sort of information. And yeah, so we pretty much designed the code and the methodology for that. And we're also tackling a third challenge, which is usually how to make MMMs actionable. Because in the past, usually they were more like annual or like semester processes where people would make decisions. And sometimes, even when they would make the decision, it was too late, right? So at that moment, it was like, okay, do we really need an MMM? Because every time I want to make a decision, it's already too late. And in this case, for Robyn, we're enabling a higher frequency of reporting. We have a refreshing function. I'm going to talk about that later. And we are allowing for more sensitivity and different aspects that can allow for better reporting and to be embedded even in dashboards on a weekly basis, on a daily basis. So jumping into the different parts of the model, we have certain modules. We have four big modules there. All we gotta understand from this is basically, first, we're gonna do all the variable transformation that Iggy was just speaking about. So the lag effects, the ad stocking, which are the delayed effects in time of media and purchases. So between you receive an impression and you buy, there's usually some sort of delay. And we also take care of the diminishing returns curves that he mentioned, plus an extra component, which is profit. So we do seasonality, trend, and holidays decomposition. Have you ever heard about profit? Because I know it's very well known. Yeah, okay. Yeah, I'm confirming it. It's another open source library from Meta. And we're using it for that. Basically, I'm going to talk about that later, but we just run it and use it later. After we do that, we run the regression per se with an algorithm that is genetic and it's gradient free. It's called Nevergrad, another open source package from Meta. And we offer two different types of nice add-ons, which are one, the budget allocator. The budget allocator is going to allow for actionability. It's going to let you know what are the best distributions of budgets that you should be doing or impressions, depending on past data and how you could improve your total response or your total sales. And the refresh is more like, again, this actionability point of view, but regarding more like the cadence, right? So if you have weekly new data, more like latest data, you want to update your model on, you have this refresh function that's going to be very handy for you. So that's pretty much the 4 modules that we have there. And what we wanted to emphasize today on is the main techniques that are trying to tackle this human bias. This is basically the automated hyperparameter optimization mechanism. It's a long name, but again, this is basically the Nevergrad algorithm we were talking just before. And what do? We apply this algorithm in a way where we have a Pareto optimal distribution of the optimization. And we do that selecting a set of different objective functions. One of the objective function is basically the error, which is very common, but in this case it's the normalized root mean square error. And then we also add something that is pretty handy for model selection, which is a score that tries to balance out the radical results in MMMs. Because sometimes when you run MMMs, and people who run it, I remember some of you raise your hand, you'll see that, in some cases, MMMs attribute to certain channels, like maybe 100% or 90% of the effect, and we know that that's not actually what's going on in reality. So we do have this decomp RSSD score. You're gonna see it over there on the y-axis. And that's gonna help out balance out the error with the business sense of things, right? So that kind of like a balanced out MMM. When we also, if you like to apply calibration or run a randomized control trial and then input it within the model, there's also going to be that third objective working there. If you see this chart over here, you're going to see there are like several iterations. The darker the color, I'm not sure if it's, yeah, we can see sort of the colors that are darker a bit to the left. This means basically that the algorithm is kind of like evolving in time after each iteration, and it's getting better and better results. The main goal is to try to get like results on the lower left side. Basically what we do later, once we have all these iterations and they're like drawn like this, you can set a set of Pareto front lines, which are these orange lines that you may see over there. And we just like, draw outputs for those, and then we clusterize them, but I'm gonna talk about that later. So we go through lots of iterations, lots of different models and possible combinations of hyperparameters until we get to the best solution in a Pareto optimal way. That's kind of like the...
Actually, some people ask us, why is it called Robyn? Is it someone's kid, or do you like the singer? It actually means ridge regression with hyperparameter optimization. But it doesn't really roll off the tongue, does it, right?
Yeah. So on the next one, yeah. So the other thing I just mentioned before, but I'm gonna go a bit deeper. Analysts usually have the challenge to also determine what are the repetitive patterns in time series, and that's where we put, Prophet. We use Prophet in Robyn, and also the multicollinearity aspect is another problem that we have. So basically, we use these two, main concepts and functions, so Prophet and ridge regression from GLMNet in R. And in the case of Prophet, we get, basically we run everything before we start the modeling, as I was showing you before in the model flowchart. And we decompose even to week seasonality. So we can do like week, monthly seasonality along the year. We can get the trend decomposition. You can see that on the charts over there. And we use that as an input variable later for the further modeling. In the case of ridge regression, you may know about it. It's usually very common. We wanted to remain simple, remain frequentist in this case, easy to understand for everybody. And of course, we know that marketing channels like TV, Google, Facebook, they're usually having a lot of multicollinearity. Sometimes when you invest more in Google or TV or some channel, you are basically sometimes doing it at the same time because you have maybe a campaign or some like new product to release, and that's something we want to treat through this mechanism. So if we go into the next one, basically we have an extra couple of techniques that we also use, and these ones are a bit more focused into selecting the right models. So remember that we saw the chart with the blue dots and everything, so there are many models you can imagine, and from those, which might be 20, 30, depending on the results, instead of having to go one by one after another one, we do apply a k-means clustering method, which is done on an ROI basis, and we try to balance out the minimum combined errors and this weighted sum of squares and so on. Try to get like a set of results that is a bit more consolidated, like this one on the orange lines, orange bars that you see there. Instead of having maybe like 20, 30, we usually offer like 4 or 5. And that's gonna be easier because at some point in marketing mix, what you gotta do is, to sit with your marketing team and try to sense check in terms of business all the, the different models that could be chosen, and pretty much choose one that makes most sense, not only statistically, but also in terms of business. And that's where this clustering becomes really, really handy. The other thing that we do is we provide the convergence sort of charts and scores, which you're going to see it's below the chart. There are some scores there. Well, that's also the scoring for the convergence. And it's going to let you know if maybe you should be iterating a bit more or a bit less to try to get to a distribution that is more solid for the objective functions. We also do that convergence for the hyperparameters to also know how they evolve after each iteration of the process of the optimization algorithm. So all that can help you understand, okay, shall I put more iterations? Shall I put maybe less? And I can do it quickly. So that's another pair of nice techniques that we can use. And remember, we talked about one of the three main aspects that we want to tackle with Robyn. Well, this is calibration and aligning with the ground truth. Again, all MMMs are regressions. They can be pure correlation in the end until you input some causation data or causal data. We really want to know how much of the sales or conversions were caused by certain channel. And to do that requires randomized control trials, could be for example, at Meta, we offer conversion lift, but it could be also geo-lift, geo-based experiments, where you like have treatment and control in certain areas. It could be sometimes time series blackout periods where you just turn off a channel and turn on a channel, and then you compare. Things like that can be inputted there. Also, you could put attribution, which you have to be very careful because it could be biased too. And you basically define like a range for the study. Maybe you run it for a couple of weeks in July, then you just set like the dates in Robyn and tell which is the total incremental absolute value for that channel. And the model is pretty much gonna go through the full iteration process and the optimization process with that extra objective function and parameter. It's going to try to minimize the mean average percentage error between the decomposition of the model and the actual absolute value that the study results have.
This is
yeah, it's hard to manage.
This is something that we really recommend strongly. Not only for the meta channels, but for any, there is a lot of digital channels that offer you the opportunity to run experiments. Forward, sometimes you have some experiments, but they might not be super suitable to calibrate MMM models. So in which case we say, why don't you then set up some, total account, enough power, no multi-cell, all of that stuff. So in order to calibrate specific channels, be it on Meta it's easy, but on other channels as well, I believe a lot of the other digital channels offer this, but also others.
Yeah, like the case of out of home or TV or things that are more traditional, then they get harder and harder. Usually it's the blackout periods that I mentioned, what's more common for those channels. Of course, GeoLift too, but in many places, like in the States, you can buy DMAs. I don't know if you ever heard about DMAs, but sometimes you can buy certain geo areas for TV, and that would be easier to kind of test, but in other countries, it's pretty much impossible. So the options are like blackout periods, things like that, and even using Profit for that. Cool, so calibration, really important. Besides this calibration aspect and the fact that we are automating all the process of iterating through the ad stock and saturation curves, the final aspect is the actionable decision making. And we do that by offering the budget allocator, which I mentioned in the flow chart. You'll see that in this case, we use a global and local optimizer for global minima and local minima. In the end, it's just to try to be sure that whatever minima we choose is not just local. We use like the sequential least square quadratic programming and the augmented Lagrangian method for that. And basically what we do is you'll see there are like a set of curves over there. Each of the channels is going to have one assigned, and it's going to embed the ad stocking and the diminishing returns sort of behavior there. And the optimization algorithm is just going to go to each of the next dollars, do the gradient because they're gradient based, and kind of like assign where each dollar should go to each of the curves depending on how they look like in terms of slope. The budget allocator pretty much just tells you, okay, how you should be investing your initial versus optimized, spend to get more response. You can choose either average response based on previous data, or you can choose like a target investment. Maybe like, you know, you're going to invest like $1 million in the next 3 months, so you just put $1 million in a max response, and then it's going to calculate that for you too. Well, one of the main things, I was talking with the guys at King before, one of the main things that people like about Robyn is also the outputs. So we have, usually every time you run a model, each of those models that we select are going to throw out a set of outputs. The first thing is the one-sheeter. The one-sheeter, it's going to tell you things like, okay, how's the model fit, how's the waterfall decomposition and the share of effect and spend, how's the average ad stocking for each of the channels, the QQ plots for residuals and like random residuals checks, and things like that, and diminishing returns curves, we just talked about. So all of that can be really handy when sitting with the marketing teams, understanding if everything makes sense in terms of business, not just on statistical values, right? We also have another outputs, yes, which are like we have Excel, CSVs, and so on, that can be used to pretty much understand which are the parameter values, the decomposition, and all the different details of each of the models that we iterated after. And we do that for the refresh function and the budget allocator too. Okay, so those are the benefits we just went through, and I just wanted to share with you, Iggy and myself, we wanted to tell you what are we after. This is, again, a community effort, so we've been listening to many of you who are working already on Robyn, and we have a certain set of lists that we think we're going to work on in the near term. The first thing is the Python wrapper I just mentioned before. We're gonna, yeah, I hope we can have that soon. Many people really use Python, we know that. At the moment, what we're gonna do is a wrapper, because we know that we're gonna keep adding lots of new things in the R code, and we cannot like handle the, parallel coding at the same time. So at the moment, we're gonna do that, and then very likely translate that next year. Then we're also gonna work with nested modeling. Nested modeling is basically useful when you have different use cases, like many countries that you model separately. Maybe you get a better R-square, a better value or like variance explanation. And then you can embed that within a bigger model. So that's something we will be working on. Also, even to model interaction effects. So in marketing, it's very common that people want to know what's the effect of investing, for example, in TV. What is the effect in Facebook? Like kind of like the interaction effects between each of the channels and how they both work in a synergistic way to promote more sales and so on. So that's another use case for nested modeling. We also have the forecasting mechanism. Some people are willing to have things, results that are more contextualized, like in more like upcoming cycles from the moment they're analyzing the data. Usually MMMs, how Robyn works is that we're analyzing past data. So when we do all the analysis, we're just saying, okay, if you would have invested better, you should have maybe changed this or that. So one of the main asks right here is like, what if I have a next cycle where I know it's like my top sales in the year? Maybe we have like a couple of months. Yeah, no problem. We have a couple of months that are like top in the year, like most sales happening there. What do we do? Then maybe a forecasting tool could be a good answer to that. And that's where we're going to work on. Time series validation is something we used to have. We're going to revamp a bit, which is out of sample validation, trying to see how much the model is overfitting or not, and comparing that. We do have rich regression, but we guess we're going to need the out of sample validation too. And it's also very much asked by the community. Finally, we have already a UI that you can try. Yeah, it's pretty nice for people that are not that used to R or like coding per se. And it's gonna bring like a nice way to interact with all the inputs, all the concepts, the marketing concepts that are behind building an MMM, and considerations. So maybe for example, if you have a marketing analyst that is courageous and he wants to like learn a bit more about modeling, that's the right way to go. They can look into the UI. It's a shiny app on R, and they can pretty much just like tune the parameters, see how the model change, and so on. So for educational purposes, we believe that's a really nice add-on. I mean, it's already there. We are gonna put it in dev very soon. And with that.
Oh yeah, with that.
Oh yeah, I'm forgetting something I mentioned, but I didn't show you the slides for that. So basically, again, this is an R package, so you can pretty much do install packages Robyn. It's in CRAN, it's up there. We're very proud we got it in CRAN a couple of months ago. It's usually pretty hard to have things in CRAN. Yeah, so if you want to try it, it's even like installing it like that, or you can go to our GitHub page, the code is there. We also have a demo, so if you go to the demo, that's key because it's gonna guide you through what to do, what not to do, and how to test with dummy data that we offer. Do you want to say something?
Yeah, the stable version will obviously be in CRAN, but if you want some of those more experimental features, then
exactly.
we'll go to the GitHub.
Yeah, in CRAN when you download it, but usually the demo, if you go to GitHub demo, then it's gonna make you do this, like install packages. So it's always gonna be the sort of stable version that you can try on the demo, if you follow the steps, of course. And then we have, as I mentioned, a Facebook group. It's not here, but I added it. Yeah, we have it. We can add it later for you to have it there. We also have the GitHub where we invite you guys to like share any issues, any problems you may have there on the GitHub page. Plus the website. The website has lots of information. There's an analyst guide for more like the nuances of marketing. Can help you out on that, and the quick start guide also for running the code.
So I think we would like to have some time for questions. So I did have a super quick case studies. I'm not going to actually show them very fast, but they are all on our website. We have success stories, for example, resident, Israeli e-com. They were able to implement this in like 5 days. So it's really, a lot of the time we hear about the speed of this. How quickly can you go from the zero to an existing model? So these guys, for example, in 5 days, Witchen, I think they are in Poland, they produce wheelie bags, again, much faster than what was their usual process, and we're able to like drive a lot of value from there. Bark, I'm not entirely sure what they do. They're some kind of doggy company in the US. They also they went in 3 months from zero to complete hero. Like they were able to start the process with Robyn, and in 3 months they were on. Other cases, even companies like Unilever, who invented MMM, let's say, right? Like they were in the original group of companies that invented it. Coppel, I think they are a Mexican department store. App-based gaming advertisers, Twikio agencies, like a lot of companies are leveraging this. So we definitely, if you are into this or your marketing department, let them know. A lot of companies are finding great value in it. It's all completely open source. Here is the slide, Leo.
That
we have
there
it
is. Sorry.
So we do have the community group. Please join it. Ask us questions, interact us. We are here all day. Most of the
also,
day.
just to add on what you were saying, there's also lots of consultancy firms and agencies, as he was saying, that are starting to consult on Robyn. So, yeah. We encourage you to try it and then see if you can help us out with the community.
Thank you.
Thanks.
So we're just going to open up the doors, just try and cool the room down during the Q&A session. So please bear with the noise. We've got about 5 minutes, maybe 4 minutes now. I'm going to get the guys just to repeat the question as it's read out. So if you can just speak loudly and they'll repeat.
So the question's around optimization. So you say that you want to kind of reduce the amount of kind of manual input that goes to, but some channels, some media channels, you would probably maybe never go to zero like this. And some maximum value will always be very, very small. Because like brand search, like the ad stock on that is like nothing basically. Whereas for TV, it's unlikely that it's ever going to have like a zero value. So do you think there's still a need to kind of actually
So the
You wanna
question was about hyperparameter bounds, I would say. And is there any need for, you know, some of the channels may have, or we may have some knowledge about them prior. So the quick answer to that is that you can either set it completely unbounded, that you just leave in the algorithm to search the whole space to find that optimal, or you can limit it. You can say we expect, or we have a prior research, or we have a prior knowledge that it's between 0.3 and 0.6, or you can even remove that need and you say it's 0, or like it's 0.1 to 0.1. So then you don't actually. So it really depends on how. So it's fully customizable in that sense. But what we have seen often is that it's better to have the algorithm pick the right one, and specifically, you know, if there is a calibrated way to do it, then that's ideal. So if you would have an experiment on branded search is super difficult to model, right? I mean, to begin with, but high correlation with everything. But I think calibration would probably be my best answer. Leo, I don't know if you want to add anything.
Yeah, I think we can switch to. I think you pretty much answered. So yeah, there's bounds, and you can choose bounds or even like strict, make it more strict. We already have a set of bounds per digital or traditional channels, but in the demo. But you can definitely like narrow it down and make it your own in the end. Yeah.
I have a question. So, can you hold this solution and framework as an AutoML? Because as far as I understand, you still need to do some tuning of parameters. And do you target to make it AutoML solution, like in what horizon?
So yeah, basically, if it's an automatic machine learning sort of technique, right? And there still requires, yeah. In fact, your question is yes. The answer is, it still requires fine tuning. It's semi-automated, right? It's not fully automated. As we mentioned before, there are a lot of nuances in marketing which you're gonna have to work with. And there are some SaaS programs, right? Like we are planning to have, right, Iggy?
Yeah. Yeah. So there is a. We've seen companies who built on top of it, like a SaaS-based version of this with a full-blown UI that does this. But that said, if you build your model once and then you pick the right model, you can sort of, you can pipe this and you can have these weekly refreshes without actual intervention. So I would think of this as more like a piano tuner model where you build it once every 6 months and have it run weekly, and you report in your dashboard, and then every now and then you make sure that this haven't diverged fully and you can rerun the model. So in that sense, this is already possible, but we're trying to make it even easier.
I know there are a couple more questions, but we're fresh out of time at this point. So I know the guys are around. They'd be delighted to see you if you can track them down out there. But let's just thank Igor and Leonel once again.